this video, we want to look at making accurate and precise measurements in chemistry. The terms accuracy and precision are often used interchangeably, and they probably shouldn't be used interchangeably. Accuracy refers to having the correct value, the correct measurement in the lab, which obviously then means that there's not a lot of error in your measurements or your data. So for example, if I know that the density of water, is 1.00 grams per milliliter. I can look that up on an MSDS sheet. That's a constant. Any sample of water should have a density of 1 gram per milliliter. If I'm doing a lab and I'm trying to confirm that by measuring the volume of different mass samples of water, whatever my procedure might be, if I really get 1 gram per milliliter, I would say that my data is accurate. I'm getting the right answer. Precision is a little different. Now obviously in the lab, if time allows, we always try to run multiple trials. We try to confirm our results, or maybe if our first trial had some error, we want to run it again until we feel like we're getting consistent data. Precision refers to having reproducible data. Oh. Now there are a few other ways that we can look at this topic of precision, according to what kind of measuring tool we're using, and we'll do that in the next video. But here's kind of a good way of looking at the difference between accuracy and precision. Let's say I got some dartboards. We're going to shoot some darts. Okay, the bullseye. Let's say that is the desired location. A bullseye is the correct result. I get 3 shots. If my data is both accurate and precise, it might look something like this. 1 shot, 2 shot, 3. All 3 in the bullseye. It's accurate because I got the right result, the correct value. I wanted them in the bullseye. And it was also reproducible. So we'd say it's good accuracy and precision. If I were doing this in the lab, let's say I'm running this density of water experiment. Maybe my data is like 0.99 grams per milliliter. Let's say I run like 3 trials. 1.00. And I don't know, maybe the last trial is back to 0.99 grams per milliliter. That is darn good data. And this is one of the things that we'll talk about when we write lab reports. If we have multiple trials in our conclusion, we would want to talk about the accuracy and precision of our results. If I'm getting the desired results, I probably don't have a lot of errors. I probably make good measurements, I use good equipment, good technique. I'm getting great data. One accurate and poor precision. What if I shot something like this? I get 1 shot in the bullseye, but the rest of them are just all over the place. One's here, one's down there. I have 1 accurate shot, but overall they're not reproducible. So data might look like, I don't know, maybe I got something kind of nutsy. The first trial, grams per milliliter. And so obviously I have some errors. Errors in my measurement, errors with my equipment. We did something wrong, because that is not even close to the density of water. So the second trial, I made some adjustments. 9, 6, I don't know, we'll just make something up. Okay, it's better. But maybe I'm still like not using the electronic balance correctly, or maybe I didn't use my graduated cylinder correctly. And so finally I run 1 more trial, and maybe I get something like this. In a lab report, you'll never lose lose points for having bad data. That happens, as long as you can explain that in your conclusion. So we would explain that we made some errors in trials 1 and 2, and we corrected those errors by the time we got to trial 3, because we finally got some accurate results. So I'd want to explain what kind of errors might have occurred in trials 1 and 2. Overall, poor precision, but I finally got one accurate result. No accurate, but good precision. Okay, so what if you got something like this? You shoot 3 darts. None of them are in the bullseye, but they're all pretty close to each other. It's reproducible. So it's precise, but it's not accurate. Data like this might be, let's say you got 5.50. And you're like, whoa, that's not right. Run another trial. 5.49. Okay, that still doesn't look good. Let's do it again. 5.49 again. Something like this. Okay, so now somebody's explaining this in the conclusion of their lab report, and they'll say, overall, we do not have any accurate results, but our precision is good. Something like this makes me think that they made an error in their lab procedure or their measurements, or there was an error with their equipment, and they had the same error all 3 trials. Maybe they were using the electronic balance, and they never hit 0 when they put the weigh boat on there. Now you're supposed to put on a little weigh boat and hit the 0 button, so you're not including the mass of the weigh boat. What if they forgot to hit the 0 button every time? So their mass included the water and the weigh boat. Well, no wonder their density is too large. So they might explain something like that in their conclusion. And then again, no points lost. They have terrible data. But they can at least give an explanation as to why their results are not accurate. And finally, poor precision and poor accuracy. This is just an unfortunate day in the lab. Their results are all over the place. So I don't know, the first time maybe they spilled half their sample. Well, that's not good. We better run this again. The second time they, maybe they again didn't push 0 on the electronic balance. Whoops, that's not good. Let's try it again. Then they got, this one's closer, but it's still not right. Something like this. And maybe the third trial, we forgot to look at the markings on our graduated cylinder. Data like this would make me think that they made mistakes, and they probably made different mistakes with each trial. Their data is all over the place. So again, if they can explain those errors, that's fine. But that's kind of where you'd want to go in your conclusion, talking about the accuracy and precision of your results. Well, we can run multiple trials. Accuracy being, did you get the desired result? Precision, is your data reproducible?